Hello everyone, my name is Matt and today we'll be going over how to download and install OpenFoam for Mac OS, as well as some of the basics of getting started with OpenFoam. So one of the best methods for installing OpenFoam I found was on CFD Direct. As you can see on the link above, if you click on the Mac OS icon, bring you up to this page and you can click on the link to go to the steps for installing it. However, one thing to note is make sure to install Docker, which will give you this little whale icon up at the top of your screen, as well as installing ParaView. If you click on here, bring you to the page, and there's a DMG file. If you installed that, then finally, probably one of the most important things is actually installing Xquartz. And then once you get Xquartz, going into Xquartz, going under Preferences, clicking on Security, and making sure to allow connections from network clients and authenticate connections. With these all set up, with your Xquartz is pretty much another terminal to use. It just works better with ParaView when you try to view your simulated flow. So you can use a terminal on the Mac, but sometimes it doesn't work as well with ParaView. If you are going to try to use the terminal for the Mac, I do recommend looking at this website, openfoam.com. They have these two documents that you can download, and if you download them, you can put them into your folder under your user for these two. They will be DMS files, so when you are following along these instructions, or if you go and you go under this YouTube video, this also shows how to correct those files, and I'll show you some of the corrections that are made. So if we open this with the text edit, you can see most of this is all just comments and information about the file, but one thing is you need to add this little X host plus 127.0.0.1. That is just calling to the port of which you'll be running the OpenFoam from. And then oops. And then for the install Mac OpenFoam, you're going to want to add in this extra line here, so then it allows you to use the Docker, and which the Docker is just an environment for the OpenFoam software to run in. It allows OpenFoam to be run on many different operating systems and computers because the environment of Docker is the same. Now, on this page, I found pretty much just typing in all these codes into Xquartz terminal. this was definitely one of the best ways for getting OpenFoam set up. Right here, what you're doing is going onto this website and you're downloading the OpenFoam, and then you're setting it up to run on your computer. And again, you continue on filing system. When I did the filing system, I just did this 20 gigabyte file system, and that has been more than enough right now. If you feel that you'll need more space or something in the future, then maybe look at doing a different type of filing system, but especially for if you're in the OpenFoam class, then 20 was more than enough. Now, each time when you start up OpenFoam, if we go in and we open up a new terminal, the important thing here is that the CD is setting up what folder you're in. And so if you do CD home and then OpenFoam, and then the important thing here is when you start up OpenFoam is that you remember this little P, because that will allow you to use ParaView. If you forget it, then ParaView you may not be able to work as well with ParaView, and you may not be able to create the file to open in ParaView. Launch that, and now you're in OpenFoam. Now, like I said before, the CD is just moving into the filing system. So if we look at your the filing system, I found that on the Mac it's best to put it under the user. So you have your OpenFoam folder right here, and then in this beginning tutorial it says if you don't have the run directory, you can make the directory by typing in this code, make directory /p foam run, and that will make this folder called run. And pretty much you can store all your files in here, and you can switch in between all your different files. We do cd foam run, you are now in the run folder, and then you type in cd, and then if whichever folder that you'd like to go into. So we could go into cavity, which is this top one up here, and now you're in the cavity folder, which is where you'll then do the block meshing and then the simulations for your foam, for your flows. An important thing is to have a base folder. So when you look on here, this tutorial 0 folder is kind of the base folder. It has, I never run this folder. This folder has everything standard from when I first got it. The whole point of OpenFoam is you'll edit these text files, and by editing these you can change how big your mesh is. If you made a geometry on SolidWorks, you can bring that in. You can have you can incorporate turbulence. You could either have like a k omega sort of simulation, or K epsilon for your different types of turbulence models. And all those are you'll just simply go in and change these file types and save them before you run. So it's important to have this standard folder, because if we look under this one, you'll see that if we go back to 0 under constants polymesh, you have just the block mesh. And so that's what you're starting out with, and the block mesh is the mesh that your flow will flow through. And if you have a SolidWorks file, the SolidWorks file will be inside that mesh. And you do this by changing all these vertices. You can have, your mesh can be curved. You have inlets, so the inlet face, and by stating all these numbers in here are the coordinates of where those vertices are. And then, so you'll see that this is 0, 0, so it's at the origin, but then this is, depending on if you convert it to meters, millimeters, it will be 10 meters away from the origin, and so on. So if you see here, you have in this z-axis, there's this 0, 0.1. So essentially, in this, if we were to run this one, this would then be almost a two-dimensional flow, if you will, because we even come down. You can also add in more vertices. So if you want to, if you want to have, say, multiple blocks or something, you could add in more vertices, and say you could have two separate cubes or something that your flow would be flowing through. You could then have the walls in between them not exist, so then the flow could mesh together and converge. And probably the most important thing with this is knowing these points. So, and where these are located on the mesh. So if you see right here, you have a 0, 1, 2, 3, 4, 5, 6. And as you look at the cube, there's some pictures online that you can look up, and it will show you that that 0 vertice is one specific corner of the mesh, and that you have to make sure that all these work together. Now, under your 0 folder is going to be all your values at time 0, your initial conditions, so velocity, which that will be affecting your inlet, dimensions, and internal field. That's going to be affecting, again, velocity. You can edit these to increase or decrease your velocity. As you can see up here, you're defining your internal field, which that's the flow inside the mesh. And if you see right here, your outlet value, the initial condition, is set right now to this value up here. You also have pressure, which again, all these are just, is there a gradient along the wall? What is the pressure value? And these can all be edited to fit your specific needs. There's other, you can also have K values that you can set. So free stream values for the outlet. If you had if we are doing one of those K omega or K epsilon RAS turbulent models, then you can set your type of wall function that you want along the wall. You can set how far off, the velocity, and all that. You have your omega again for the wall function, how much turbulence you will have. Y plus again, also with the turbulence. Your new T. So again, to go back to why it's important to keep the one folder and then copy it to make a new one is, if you look here, it writes all these points. So this, based on the values that we put in under control direct, you see here you have your system, and these are set before you run your simulation. You have your start time, which you can either set to start time, latest time. If your start time 0, stop at end time, set what your end time is, how much time change you want, so in this case 1 second, your time step, how many intervals you're going to go for. And so these can all be set, and so as you see here, then at each of these steps from setting in here, it will then import all these values. And so when you go on to pair view, you can actually click through each time step so you can see how the flow changed from your initial to 10 seconds in, 142 seconds in, 624 seconds in, which at this point this is the last one, so this is when it was done meshing. And so that's all done in here. Again, these are also the schemes and solutions. These are also some of the how the data is taken in and what you're trying to go for. Steady state. What kind of solver you're going to use. The amount of tolerance that you want. So say you want to converge a lot quicker, you're going to make your tolerance not as tight, so it's going to be a larger tolerance value. So maybe something along 1 to the negative 1 times to the negative third or something instead of to the negative 6. And yeah, you can adjust that for your K and U omega values, which is your turbulence or velocity. These are the turbulence ones, the K and omega. U is velocity. But if we go back here to constant, see right here, all these new all these files are written as it's meshing, and the OpenFoam is calculating the solution, and you see all these values are written as, and these are all just the numbers as it's calculating the flow, and it writes all these values. So to just finish this off, if you are running this on a Mac, just follow the Docker installation instructions. There's really not too much to do for Docker. Also, ParaView and Xports were pretty much just applications that you could download, like Docker. I put for under users, I found that with how the tutorials are trying to run, all these files, I found it was best to put under your actual user, because it seemed like in some of them it was trying to go to the user. Then you have your OpenFoam folder. To begin with, you can make a run folder. If you want, you can make another folder. So right now I just have run. It was a nice starting point, because if right now, as you can see over here in the terminal, I'm in Cavity, I can then just go, and I can just go back to the run folder, and then I can go into any of these other folders, which makes it nice and easy spot to return to. But if you want to, you can make another folder in your OpenFoam folder to save other sorts of files. Then once, if you see down here, this CP in this beginning tutorial, so what this is doing is this is actually going into the OpenFoam database, and it's copying this tutorial. That's what the CP is. It's copying it, and it's importing it into your folder. And so that's how you can get this Cavity folder, this Pits Daily. You can get all these online by going into this OpenFoam. They have a whole bunch of tutorials that you can do, and it will show you, and essentially you're just copying all these, and it will bring it automatically into, from running this copy command, it will bring it into your run folder. And then yeah, you can copy some of these. So you have Cavity right here, but then you copied it, I copied it into Clip and made a new one called Cavity Clipped, Cavity Fine, Cavity Grade, for all the different ones that I was trying to run. And then pretty much once you have all the text files edited to where you want them to be, you pretty much are either you're going to run block mesh and then simple foam or something else. It could be icofoam, depending on how the solver that you're using and how you're trying to solve it. So if we look over here onto this other website for trying to download and install it onto, they show this other tutorial that you could use that uses icofoam. You can dive further into these different solvers and why to use them, but pretty much the straightforward thing is edit your text files, mesh it, then do the foam, then do the solver, Then once it's done, you'll just type in parafoam like this, and it will bring up your flow that you simulated onto the parafoam. It will bring up the page. Essentially, if it all works out and the file is also the paraview file is saved properly, it'll show the file that you just simulated right here, and this apply button will be green. Essentially what you're just doing is then hitting apply, and then you'll come down into here, into these properties and displays, and you can edit how the mesh is shown, so either a wireframe or saw body, how the flow is shown, what sort of data is being shown. You can, up here is where I mentioned closer towards the beginning of this video, you can click through the time steps, or you can just play the whole foam as it gets meshed through. You can click and drag around to change how the flows or how your view of the flow is oriented. You can use some of these little tools up here which can cut away, and you can get a cutout view, so you can actually see if it was like a solid body that you're doing a flow through. You can use one of these tools and it will allow you to clip and see the cutout view of that. You can also come up to here, and up here you'll have a bunch of these. You can also access a bunch of your tools up here. Filters is mainly where you'll get all these tools from, alphabetical, and you have a lot right here. Using contour, that one you can use a lot. Clip is where I was talking about with the getting the cutout view. And yeah, you can then just type into, if you want to exit out, you can just type in exit. Make sure your make sure your capitals are proper and you don't have any spelling mistakes. And now you're out of OpenFoam. To go back in, you simply just repeat these two lines right here. CD. And then you're back in. So there's other different types of solvers that you can use, like how I was showing turbulence. You can also, if you want to input a SolidWorks file, you can, there's files called snappy hex mesh that you can use, which you'd use along with the block mesh, and that's creating the mesh for your SolidWorks file. You'd put the SolidWorks file in here first before you ran it. So if you see here, you have under constants, here's this tri-surface folder which contains the two files for the SolidWorks model, and yeah, you'd run your snappy hex mesh, your surface feature extract to then, along with your block mesh, to be able to simulate the flow with using a SolidWorks part. So hope this kind of helps get you up and running, and good luck using OpenFoam.